Okay, sorry about the bad lighting in here and the casting of shadows, but I don't have much choice. Anyway, we've got a 15 kilogram box or mass that's on the rigid ground here. We've got someone pushing this box at a 25-degree angle. We'll just call that F push or force of push. That force, the problem tells us, is 143 newtons. The friction force pushing against that force due to the roughness of the surface here is 50 newtons, and we are interested in the normal force or the force that's pushing back up against the box. So what's the first thing we need to do? All right, let's draw a free body diagram. So I am going to pause here for just a moment, and if you want to, go ahead and hit pause on the screen and see if you can develop the free body diagram for that. So 1, 2, 3, 4, 5, and now we're going to this. Okay, so here's the beginning of the free body diagram. All right, let me hang on just a minute. All right, there we go. So the beginnings of the free body diagram, we've got F push, and that's coming in at this angle here. All right, so we know that's a force that we have to deal with, and then we know that this box has a weight of 15 kilograms, so there's going to be a force due to weight going down. All right. Okay, hold on just a moment here. Let's see. I need to. I don't want to show everything here all at once. Pardon my disorganization here. Okay, so next is this, and how is this comparing to yours? Okay, so that we've got the force of the weight coming down, and we've got the normal force pushing back up from the rigid surface. So that's what's supporting this. Okay, and I'm sorry the dog is over here growling. She wants a rawhide. All right, so what other forces do we have? The frictional force, and again, that is pushing against this force of push over here. All right, because we've got a rough surface that it's going against. And what's next? Okay, so this pulls everything together. This is what the free body should ultimately look like. You've got the force of the push, the force due to the weight, the force of friction, and the normal force. All right, now let's see where do we go from here. Let's see. There we are. Okay, so we're going to break down that force of push into the Y and X directions. And we've got a 25-degree angle that we're all set by. And so here's how we break that down. So the force of the push in the X direction, again, that's this. We multiply against cosine 25 degrees, because this is the hypotenuse and this is adjacent. Okay, for the Y direction, we've got the force of the push times the sine of 25 degrees, because this is opposite. Okay, so that's how you get those. How are you doing so far? All right, and next. Okay, now we've got the free body diagram, and everything is now in the X and Y direction. So this is the force of the push in the X direction. This is the force of the push in the Y. We've gotten rid of the angle here because we replaced it with its X and Y components. We now have the normal force pushing up there, and it is pushing up from the floor, but you can also translate it up here and show it that way. And you got the force due to the weight and the force due to friction. Okay. All right, so now we sum our forces in the X and Y directions, and we know that since it's, I made a mistake here. This thing is moving. Hang on.